everybody. In this video we're going to talk about variables and data types. There are several data types discussed in your chapter, several of the intrinsic or the primitive C++ data types. We're just going to talk about the ones that we'll be using most often, so that's what this video will address. So let's talk about the notion of a variable. This is a very important concept in programming. Luckily it's not too difficult to grasp. When you create a variable, you are reserving a little piece of memory to put a value. So let's say I'm creating a program for Amazon.com or something like that, and I need to store the price of a book in memory. I can create a variable to set aside just a little piece of memory, and then put the value of the book in there, $9.95 or $24.95, something like that, and then retrieve it for later use. Right? The whole point of putting a value in memory is so you can get it back out, display it to the user, calculate their total in the shopping cart, anything that you can think of to make use of that value. Okay, so not all variables are created equally. They all have varying data types. And so when you're creating a variable, you have to ask yourself, okay, what is going to go into this variable? Is it a person's age? Is it the price of a book? Is it somebody's name? Okay, and depending on the type of information, type of data that you're expecting to put into that variable, you're going to choose a data type, and we have several to choose from. So let's pretend I did want to ask the user for his or her age. We wanted to store somebody's age. Maybe it's for an insurance company or a doctor's office, and we need a person's age. So why don't we create a variable to do that? And if we don't care about fractions of ages, like I'm 10 and a half years old or something like that, if we just care about the whole numbers, then we can go with the integer type. So let's do that. We'll say int age. Now this is the bare minimum of what you need. This will reserve a memory location. Okay, and the integer, I think, will give you 4 bytes of memory, which is more than enough to store a person's age. Typically what I would like you to do is, so this is the variable, I'll write a comment here, this is the variable declaration, where you're really just reserving that memory. I would like you to also initialize your variables. You'll see a lot of programmers do this. Just start it out with a nice clean 0. Okay, or if you know the age that you're going to be putting in there right off the bat, then you can maybe put an age in there. Okay, so you have 2 and 1. You have the declaration on this side, and then you have an initialization. The initialization of the variable where you're putting a value into it. Okay, so this would reserve a memory location about 4 bytes and put a number 19 in it. Okay, or like I said, if you don't know the age right off the bat, then you can initialize that to 0. So let's ask the user, and here we'll talk about cin as well. I'm going to say to the user, enter your age. That's a prompt with cout. Always have to be very specific about what you want your user to do. And then we'll use cin to extract that data from the keyboard. The user is going to enter his or her age, and that will go into our age variable. Cin is like cout. It's a stream of data, but this is an input stream, so it's moving in the opposite direction. It's taking data from your keyboard and putting it into the variable, into the memory location. This is called the extraction operator. Remember, cout uses the insertion operator. This is called the extraction operator. Okay, be careful. You always want to, cout uses the left pointing arrows, and then cin uses the right pointing arrows. I think on one of my sheets I told you to remember the saying, I'm not left out, I fit right in. So that'll help you keep it straight. Okay, so now we've got the user's age, and we can do a little cascading here. maybe an endel. There we go. Let's run it. I'm not 19, obviously. And there we go. Okay, so that's your integer type. And that is good for whole numbers, negative or positive, negative or positive. So let's say, I wanted to store the number of students in the class. I can say int num students. Probably about, 17 of you at this point. And there you go. So whole numbers. Not good for money. Be careful. Students always just want to grab that int. Maybe because it's the first one we learn. It's just, always at the front of their minds. But when we start dealing with, little programs that deal with cost of items and little stores and stuff like that, you cannot use an integer because the integer can't handle that decimal component that comes with money. So let's talk about the next one. And this is really the one that you'll probably use most often in this class when we're dealing with money. That would be the float. And a float stands for floating point. In other words, a decimal data type. So let's say we did want to do the price of a book. How about this? $9.95. And then you have to put, well, you know what? Hang on here. I'm going to leave it at that. Okay, so we have a memory location reserved, the price of the book. I initialize it with a $9.95. I'm going to build this. Okay, I have a warning here. A compiler warning is not like an error. I can still run the program with a warning. But let's look at this because this ties into our conversation here. It says initializing truncation from double to float. And here, so what that means, and you know what, we'll hold off on exactly what that means, but I want to show you. If I put an F, a capital F, on the end of that 995, notice I'm building my solution but not running it. If you want to just compile it and see if it's error-free or if you have errors, then you can just go to build and then build solution. Whereas this one, the green, will compile the solution or build the solution and then run the program. But you notice I'm not getting my little black window when I just do a build. So let's see. Doing that, putting that F there, and I build the solution, and I don't have any errors or don't have any warnings at this point. So that got rid of the situation there. So that's a type float. And in order to explain this whole phenomenon here, let's move into the next decimal type, which is a double. And you might see something like this in your book or something along those lines. Oh, I think they actually use pi with the float. But basically, float and double will serve the same purpose. And for our class, for what we're doing, they're basically interchangeable. However, they're not really the same. The float is like a smaller, it's a smaller of the two data types, meaning it takes up less memory. And less memory means it's less precise. You can hold less decimal places with the float than you can with the double. For example, I think the float will allow you to do like 8 decimal places, which is more than enough for most applications. The double will give you like 15 decimal places. So what that was about with this 995, when you type a numeric decimal constant into your code window, the compiler, the C++ compiler, assumes type double. It says, oh, 995, that's a decimal, that's a double. It takes the initiative like that. And so what happens is it's telling you this is a double, and you're trying to put it, a double which can potentially be 15 decimal places, and you're trying to put it into a float which is only good for about 8 decimal places, and so you're going to lose that precision, that truncated warning that we talked about. The truncated means cut off, and those remaining decimal places would potentially be cut off. Now it wouldn't make a difference in this application or probably any application we do in our class, but if you were doing a scientific program where every fraction of a decimal counts, then it would be an issue for you. So anyway, if you don't like the warning, just get in the habit of putting F's after your float constants. Okay, so there we have the float and the double. This is what you'll use for money. You could use this for money as well, but what you must not do is use the integer for money, because then your cents, dollars and cents, the cents are going to be cut off. They're going to be truncated. You'll get an inaccurate result. Okay, two more. Type char, or the character. This will allow you to store a character in memory. For example, how about a student's grade, A, B, C, D, or F? And since you're all going to get A's, we'll put that in the variable. Notice that the character you have to put the value in single quotes. Single quotes. That's the way you do it. Oh, you know what? You can also put an escape sequence in a character. Even though a character, you think, okay, one character, and this is actually 3 characters, that's the smiley face escape sequence that we talked about in an earlier video. So, okay, oh, you know what? Let's comment out this thing so we don't have to run through that again. This is how you can comment out. If you want to save code, but you don't want to delete it, but you don't want to run it, just drag through it. And then here on the toolbar, do you see these? We have comment out the selected lines. And what that'll do is it'll go green on you, so it becomes a comment, so it's not going to execute. That's good if you just want to keep the code on the back burner and not run it. And then if you want to get it back, the one next to it, uncomment the selected lines. That's really useful. Okay, so let's run this. And there's the smiley face, the character data type. Okay, last one. This will come into play later, maybe not in this homework assignment, but we have the bool, which stands for Boolean, and that will hold a true or false value. So let's say I was writing a program for Moraine Valley and I wanted to store whether or not the student lived in district. I can create a Boolean data variable called inDistrict, and we'll assign it true or false. Okay, one last thing. This is not one of the primitive C++ data types, but it's probably something that you'll want to use from time to time, especially if you're used to programming in other languages. You may be familiar with a string data type, which will allow you to store a string of characters, like a person's name or Moraine Valley Community College, something like that. And that's not one of the primitive C++ data types that is available to you. So you won't see that discussed in Chapter 2 with the rest of them. That doesn't mean that we can't start using strings right away. The string does come into play, I think, much later, like Chapter 7. We're going to do that at the very end. But you can start using the string right away if you want to. However, because it's not one of the intrinsic C++ data types, you have to go through a little library checkout routine that we talked about, the stuff that you have to do for C in and C out. We have to do that for the string. So up at the top, you want to say include string. Okay? So that's going to provide us with a string object that we can use just as if it were a data type. So let's create one of those. We'll say string school equals, and notice how it does not turn blue on you because it's not one of the key words. It's not one of the primitive data types. So don't let that throw you. But that's just how it's going to be. So we'll say MVCC. Okay. There we go. So there's your string. Don't forget, if you want to use it, you must check it out of the library first.